Measuring of precipitation. Rainfall. Precipitation is expressed in terms of the depth to which rainfall water would stand on an area if all the rain were collected on it. Thus, 1 centimeter of rainfall over a catchment area of 1 kilometer squared represents a volume of water equal to 10 to the power of 4 cubic meter. So, kining tulo mo ni sila laing term sa kuan kaning rain gauge. Pluviometer, ombrometer, and yeatometer. So, a rain gauge essentially consists of a cylindrical vessel assembly kept in the open to collect rain. The rainfall catch a rain gauge is affected by its exposure conditions. To enable the catch of rain gauge to accurately represent the rainfall in the area surrounding. So, the rain gauge in standard settings are adapted. For setting a rain gauge, the following conditions are important. The ground must be level in an open and the instrument must present a horizontal catch surface. The gauge must be set as near the ground as possible to reduce wind effects, but it must be sufficiently high to prevent splashing, flood, and etc. The instrument must be surrounded by an open fence area of at least 5.5 meter times 5.5 meter of an object. Should be nearer to the instrument than 30 meter or twice the height of the obstruction. So, non-recording gauges and recording gauges. So, ang ilang differences nila ani is the non-recording gauge extensively used in India is the system gauge. It essentially consists of a circular collecting area of 12.7 cm or 5.0 diameter inch. So, connected is just a fuel. Ang recording gauge naman, recording gauge produce a continuous plot of rainfall against time and provide valuable data of intensity and duration of rainfall for hydrological analysis of storms. So, the following are some of the commonly used recording rain gauges. So, kining tipping bucket type mo ni siya kuan kanang 30.5 cm size rain gauge adapted for use by the United States Weather Bureau. The catch from the rainfall falls onto one of a pair of small buckets. These buckets are so balanced that when 0.25 mm of rainfall collects in one bucket, it tips and brings the other in one position. So, kining weighing bucket type, in this rain gauge, the catch front the funnel empties into a bucket mounted on a weighing scale. The weight of a bucket and its contents are recorded on a clockwork driven chart. Natural siphon type. This type of a recording rain gauges is also known float type gauge. Here the rainfall collected by a funnel-shaped collector is led into a float chamber, causing a float to rise. As the float rises, a pin attached to the float through a lever system records the elevation of the float and a rotating drum driven by a clockwork mechanism. So, mo ni siya example diri ang nakabutang sa figure 2.6. So, telemetering rain gauges. These rain gauges are of the recording type and contain electronic units to transmit the data on rainfall to a base, both on regular intervals and on interrogation. The tipping bucket type rain gauge, being ideally suited, is usually adapted for this purpose. So, pag maklaro ninyo diha guys, i-screenshot na laman or i-kuan kay lisod na diri di maklaro way kuan eyeglasses. So, radar measurement of rainfall. Snowfall. So, snowfall as a form of precipitation differs from rainfall in that it may accumulate over a surface for some time before it melts and causes runoff. So, depth of snowfall. So, depth of snowfall is an important indicator for many engineering applications. And in hydrology, It is useful for seasonal precipitation and long-term runoff forecast. So, water equivalent of snow. So, water equivalent of snow is the depth of water that would result in melting of a unit of snow. So, this parameter is important in assessing the seasonal water resources of a catchment, as well as in estimates of stream flow and flood due to melting of snow. So, water equivalent of snow is obtained in two ways. Snow gauge, like rain gauge, snow gauge are receptacles to catch precipitation as it falls in specified sampling area. Here, a large cylindrical receiver 203 in diameter is used to collect the snow as it falls. The height of a cylinder depends on the snow storage needed to spot as consequences of accessibility, etc., and may range from 60 cm to several meters. So, snow tubes. Water equivalent of accumulated snow is measured by means of snow tubes, which are essentially a set of telescope metal tubes, while a tube size of 40 mm in diameter is in a normal use. Higher up to 90 mm diameter are also in use. The main tube is provided with a cutter edge for easy penetration, as well as to enable extracting of core sample. Additional length of tube can be attached to the main tube depending upon the depth of snow. So, rain gauge network. Since the catching area of a rain gauge is very small compared to the areal extent of a storm, it is obvious that to get a large representative picture of a storm over a catchment, the number of rain gauge should be as large as possible. So the catchment area per gauge should be small. In flat regions of temperate Mediterranean and tropical zones, ideal sa Station 1 for 60 to 900 km squared. Acceptable 1 station for 900 to 3000 km squared. So in mountains, region of temperature, Mediterranean and tropical zone, ideal 1 station for 100 to 250 km squared. Ang acceptable 1 station for 25 to 1000 km squared. In arid and polar zones, 1 station for 1500 to 10,000 km squared depending on the feasibility. So 10% ani sa gauge stations should be equipped with self-recording gauges to know the intensifies of rainfall. So adequacy of rain gauge station. Mao ni si Jay nakabutang diri If there are already rain gauge station in catchment, the optimal number of stations that should exist to have an assigned percentage of error in the estimation mean rainfall is obtained by statistically analysis. So n equals to CV over E close parenthesis squared, where n optimal number of station, E equals to allowable degree of error in the estimate of the mean rainfall, and CV is equals to coefficient of variation of the rainfall values at the existing M station. In percent na siya. If there are M station in the catchment, each recording rainfall values P1, P2, P3, and so on. So, in a known time, the coefficient of variation CV is calculated. So, CV equals to 10 times UM minus 1 over P. So, where UM minus 2 is equals to square root of kung ko na nakadi na maklaro dire kaadto. So in calculating n from equation 2.3, it is usual to take A equals to 10%. So it is seen that if the value of A is small, the number of rain gauge station will be more. So according to WMO recommendation, at least 10% of the total rain gauge should be on self-recording type. So additional 3 stations are needed: preparation of data, estimation of missing data, test of consistency of record. So for test consistency of record, if the conditions relevant to the recording of a rain gauge station have undergone a significantly change during the period of record, inconsistently would arise the rainfall data of that station. So mao ni ang isang example 2.3. So presentation of rainfall data. A few commonly used methods of presentation of rainfall data which have been found to be useful in interpretation and analysis of such data are given as follows. So mass curve of rainfall. The mass curve of rainfall is a plot of the accumulated precipitation against time, plotted in chronological order. Records of flow type and weighing bucket type gauges are of this form. So money Yetograph. A yetograph is a plot of the intensity of fall against the time interval. The yetograph is derived from a mass curve and usually represented as the bar chart na as 2.10. So, it is very convenient way of presenting the characteristics of form and is particularly important para sa development designs of storms to predict extreme floods. So, the area under the heterograph represents the total precipitation received in the period. So, makita ninyo diha The time interval used depends upon the purpose. In urban drainage problems, small durations are used, while in flood flow computations, in larger catchment, the intervals are about 6. So, point rainfall. Point rainfall, also known as station rainfall, refers to the rainfall data of a station depending upon the need. Data can be listed as daily, weekly, monthly, seasonal, or annual values for various periods. Graphically, these data are presented as plots of magnitude versus chronological time in the form of a bar diagram. So, moving average. Moving average is a technique for smoothing out the high frequency punctuation of a time series and to enable the trend, if any, to be noticed. The basic principle is that a window years is selected starting from the first set of in years of data. The average of the data for in years is calculated and placed in the middle year of the range. So sa figure 2.11 bar chart of annual rainfall at station M. Mo ni siya sa 1, 2, 3 ang 1 year annual rainfall mo ni diyang PI in millimeter, 3 consecutive year total for moving mean o 3 year moving mean. Mean precipitation over an area nas figure gihapon 2.12, 3 year moving mean. Arithmetical mean method. So when the rainfall measured various stations in a catchment show a little variation of average precipitation over the catchment area is taken as the arithmetic mean of the stations. Thus, P1, P2, PI, and PM are the rainfall values in the given period. In stations within a catchment, then the value of the mean precipitation P over the catchment by the arithmetic mean method is. Isoetal method. The area between two adjacent isoetes are then determined with a plane meter. If the isoetes go out of catchment, the catchment boundary is used as the bounding line. The average value of the rainfall indicated by two isoetes is assumed to be acting over the inter-isoete area. Thus, P1, P2, and PM are the values of isoetes, and if A1 and A2 and AM are the inter-isoete areas respectively, then the mean precipitation over the catchment of area A is given by the catchment is drawn on the scale and the stations are marked on it. Figure 2.15. The stations are joined to form a set of triangles and perpendicular bisector of each side is then drawn. So the adjacent polygon area enclosing each station is then identified. It may be noted that station 1 in this problem does not have any area of influence in the catchment. The areas of various station polygons are determined either a plane meter or by placing an overlay grid. So makita ninyo da sa example figure 2.15. Depth area of duration relationship. The areal distribution characteristic of a storm of given duration is reflected in its depth area relationship. A few aspects of the interdependency of depth area and duration of storms are discussed below. The maximum depth area of duration curve. In many hydrological studies involving estimation of severe floods, it is necessary to have information on the maximum amount of the rainfall of various durations occurring over various size of areas. Sa figure 2.16.